So far, we have predicted house price based on square footage by using linear regression with single variable. But think about it, when you buy a house, does it depend on only a single parameter, the square footage? No, we consider so many things when buying a product. For a house, let's say we see number of rooms, the tax, etc. Also, we see definitely many other parameters like location, appliances like lights, fans, etc. So here's our data set. The file is houseprice.xlsx. To read this, we use p.readxl command, which comes from pandas. And when we see the data frame after incorporating into our, after reading it from pandas, we see the data frame. We have three independent columns: square footage, room, and text. You can see that the square footage, the number of rooms increase, and also the tax increases, and also the price increases. So in this case, we don't have just one parameter, rather we have several parameters. And we would like to predict the price of the house. Here's another problem in our tax column. One value is missing. There is no numerical value, so it's showing none here for this particular row. If we visualize this column particularly, we write d of the tax, and if we run this, we see this. Now, how do we resolve this issue? We can do replace it. We can replace it with the mean of this column or median of this column. Popularly, we do mean or median. Let's see how it is for this text column. If we use this command df.text.mean and visualize it, we can see that the value is 5. So the mean of this text column is actually 5. On the other hand, the median of this column is 4. So we know what the mean is, what the median is. We can replace the absent value or the missing value with the mean value. In this case, we have to use this command. Let's say that we want to fill the missing value of this text column with this command. Fill NA with text new1, which is the mean value. That is 5. And after that, if we visualize the column again, we can see that there's no longer the missing value. It's replaced by the mean value. Now we can visualize this data frame again, and we can see that there's no longer the mean value in the text. Now we do the similar implementation of linear regression. We import learn.linear model. We import linear regression, and we fit our data to this linear regression algorithm. 3 columns, we have to fit just this to predict the price column. And let's say we have several columns, right? We have several rows, 100, 200, and 300. Let's say we want to predict for a particular combination. Let's say we want to predict for 150, square footage is 150, and one room and tax is 2.5. Then we can predict that particular value, 150, 2.5, and after we run this, we can see that the result is something like this, 1216.15. So basically, it's a value between 1000 and 2020, according to the linear regression model. And we know that for one variable, it's y equals to mx plus b. But in this case, we have 3 columns. We can we can say that the equation is y equal to m1x1 plus m2x2 plus m3x3 plus c. So when we try to see what coefficient is our algorithm, we can use reg.coef. There will be a score after this, and it will show us the coefficient. This is the M1, this is the M2, this is the M3. So we are assuming that our price is dependent linearly on these three parameters. So that's why instead of just one coefficient, there will be three coefficients. And to know the intercept, we use this command reg.intercept score, and we can manually see how these 12, 16 comes. We can actually manually write down the equation. So M1 and X1 from here plus M2, which is here, and X2 and M3, which is here, and X3 plus C, that is the intercept. If we manually calculate it, it will come to this particular value, 1216.15. So that's how it's being calculated here when there is a linear regression with multiple variables involved. So basically, we're using the same linear regression, but with multiple variables. Now, how do we know how good performing our algorithm is? There are several ways to measure. For linear data, we can measure our squared value. If it's closer to 1, it means that closer to a perfect linear fit. If it's less, say 0.2, 0.3, then it's not a good linear fit at all. You can just make a little Google search for R squared value. So let's complete the tutorial on linear regression with multiple variables. Hope it's helpful. Next, we'll learn polynomial regression. Thanks.